Hi guys, Mlungisi Nkosi here, and once again we're back together. Today we'll be looking at financial mathematics. We're still continuing with that, and if you haven't subscribed, please just make sure to hit that subscribe button, okay? Let that be the first thing that you do before watching this video. And of course, for those of you who still need assistance with mathematics or physical science, you're more than welcome to get in touch with us, and our email address is info@mlungisinkosi.co.za. We're going to be looking at timelines today, how to construct timelines, and how that will affect how we look at financial maths. All right, let's get into our very first lesson. All right, let's talk about timelines. So first of all, why would we want to have timelines when it comes to financial mathematics? Well, timelines actually give us a way of summarizing data, in a simplified way. Okay, for instance, sometimes you have an initial investment. Let's say, for instance, just invest a certain amount, 60,000, just a figure that I'm taking from the top of my head. But several things happen within an investment period. For instance, you find that perhaps the interest rate changes between the different years. Let's say the interest rate changes between year one, let's say from T0, T1, T2, T3, T4, and T5. Now, if we were to apply a different interest rate here, let's say 9%, for instance, and we apply a different interest rate between year 2 till year 5. So it's easier for us to summarize that data in a timeline so that you can see the different rates that are applicable. Or sometimes you find that during the investment term or the loan term, maybe a deposit is made, okay? So in case you make a deposit, you can add it onto there. But in this case, that extra deposit does not form part of the 60,000 rands that was initially deposited, or whatever the case is. Or even sometimes you find that you make a withdrawal. Okay, so some of the money was taken away, or whatever the case may be. So what we're going to do all the time is make sure that we summarize in terms of a timeline. So what I want us to do quickly is to take an example that would illustrate this, and so that we can see how we are going to apply this. Now, just before we go into that example, just remember that we are going to look at the amounts that are deposited and withdrawn separately, and at the end of the day consolidate, depending on what is done. For instance, if I took the 60,000, remember the 60,000 would have stayed throughout the period, the 5-year term in that case, that it is invested in, right? Now, if we made a deposit here, we cannot count it, or rather we cannot take the accumulated amount for the 5 years. It would actually be now for the remainder of the years that we would have. So in a sense, what timelines help us do is to take our information and simplify it graphically. It's much easier for you to deal with a graphical representation rather than data that it is in form of words. Right, now let's take our first example. Right, now they say to us 5,700. Okay, that's our first example. They say it's deposited into a savings account. So that's our initial amount. And 2 years later, another 1,900 is added to the savings. Okay, so we know this is after 2 years. Right, and then they say a deposit of 4,100 is made 5 years after the initial deposit, and the interest rate is for the first 3 years. The interest rate is given to us as 13% per annum. Okay, all right, and it is compounded quarterly. All right, so we know that's a quarterly compound interest. Okay. And it is then decreased to 11.2%. So we need to note that Now it's compounded monthly. Right, now they say calculate how much money is accumulated to the savings account or in the savings account at the end of 8 years. Now, so this is where we're going to use a timeline to make sure that we make a graphical representation. So first of all, we know that we've got 8 years. Okay, so that's 1, 2, 3, 4, 5, 6, 7, and 8, right? So that's, we'll call that T0, T1, T2, okay, 4, that's 5, that's 6, that's 7, and that's 8. So we're looking at year 8 in that case. Right, we're in, sorry, that will be, the maturity of our investment. Right, so first of all, we know that they deposited. So there was an initial deposit of 5,700, if I remember correctly, right? And then they told us that after 2 years, we now added 1,900. So in this case, year 2, that's 1,900 rands. And then we also had another deposit 5 years after the initial investment of 4,100 rands, right? That was deposited. Now, the difference now is on the interest rate. Remember, they told us that we have an interest rate of 13%. I think they said for the first 3 years. Okay, let me just verify that. Right, we have an interest rate, of 13% from year 1 to year 3. So we know we had an interest rate of 13%. But please remember, they said this is compounded quarterly. Okay, right. And then we know that thereafter, we took an interest rate of 11.2%, right? 11.2% per annum. But in this case, it was compounded monthly. Okay, right. So now what we want to make sure of is, how then do we deal with this data in the case of, the final, withdrawal in the case of year 8. Right, now let's start here. So let's deal with the 5,700. So we're going to deal with the 5,700 on its own, right? So in this case, what happened in the case of the 5,700? I'll call it accumulated amount 1, right? Now, it was invested for the entirety of the 8 years, but 2 things happened, right? First, it accumulated interest at 13% per annum, right? So I will take the future value, or in this case, the accumulated amount at year 3, okay, at 13%, right? And whatever is the accumulated amount at year 3, I will therefore take that amount as my principal amount for the rest of the 5 years that are remaining. Okay, so that's 1, 2, 3, 4, and 5 years, right? So in this case, how would we get that accumulated amount? So we know it's principal amount 1 plus interest over the number of times it's compounded per year, okay, and multiplied by m. Right, now I am going to simply say, so that's 5,700, okay, and that would be 1 plus. Now our interest rate, remember, we always divide that by 100. So that's going to be 13 divided by 100, that's 0.13, right? It is compounded quarterly, so we know that's going to be divided by 4. But how many years was it, did it accumulate interest at 13%? It's 3 years, so this is going to be 3, but remember we multiply that by 4. So that would be 12 compounding periods all in all. Right, now, in this case, I'm going to say, look, so whatever amount I get here, that would now be the principal amount from year 3 up until year 8. So this principal amount now will accumulate interest, will begin to accumulate interest at 11.2%. So that principal amount now begins to accumulate interest. So that would be 1 plus 11.2%. That's 0.112. Now it's monthly. So this is going to be divided by 12. But how many years was it? It was 5 years, right? So it's 5 years from year 3 to year 8. That's 5 years, but we know that we are doing that in 12 months in a year. So that's monthly. So that would be multiply that by 12. Okay. So ladies and gents, if you don't mind, what I'm going to do is I'm not going to calculate this amount. What I'm going to do is I'm going to put all of these amounts at the end, so that I don't keep rounding off. Okay. Right. So when I take my accumulated amount, you can if you want to, but just be careful of rounding off too early. Right. Now, we've dealt with 5,700. Now, let's go to the next value. I'm going to put that in a different color. So let's deal now with the 1,900. So we made a deposit for the 1,900. Right. So we made that at the 2 years after our initial deposit. So do you agree with me that it would accumulate interest for only 1 year, right, at 13% per annum? So you would only find 1 year where it was compounded at 30% per annum. That is on a quarterly basis. So now let's deal with that. So I know my principal amount in this case, that would be the 1,900 this time around. So that would be 1 plus, in this case, my interest rate, still at 13%, 0.13 over 4 multiplied by its 1 year, right? But it's 4 months in that year, right? So you would get an accumulated amount at year 3. Now the accumulated amount for the 1,900 becomes the principal amount at year 3, and now it begins to compound in interest at 11.2% per annum, but this time on a monthly basis, right? So that amount now becomes the principal amount for the next compounding period, right? But in this case, we're compounding at 0.112, right, divided by 12. Remember, it's monthly this time around. And this is now, remember, this is the next 5 years. Okay, so that's all of those years there until year 8, from year 3 to year 8. So that's 5 years. But this time, that would be multiplied by 12 because that happens on a monthly basis, right? Right, so we've dealt with the 1,900 deposit. So I'm going to leave that there so that we take all of the amounts together at the end. Right, so let me call this A2, accumulated amount 2. Right, now let's take the next one. Maybe let's write that in a blue color. Okay, so let's call that A3. Now, I am dealing with the 4,100 that was deposited, right, at, they said 5 years after the initial deposit. So how many years does it have to actually accumulate interest? It only has 3 years. Can you see that? But please remember, in this case, it wouldn't accumulate interest at that initial 13% because it only was deposited when we were having an interest rate of 11.2% on a monthly basis. So for the 4,100, we'd have the principal amount, 4,100, 1 plus, so this is 0.112 divided by, remember, it's monthly, okay? But remember, it was done at year 5, right? So we only had 3 years, but remember, this is on a monthly basis. So that means that my final accumulated amount, okay, would be A1, that was in white, plus A2 in yellow, plus A3, which is in blue. So what I'd like for us to do, just do that quickly in your calculator. Okay, take all of that, multiply it, okay, and get the final answer, right? And then we are going to add the answer to that, okay? So what I did for myself is that I tried to do it beforehand so that I can get all of those values. You can verify those values for me. And the final accumulated value that I got was 24,108 and 19 cents. So that would be the amount that we would have at the end of 8 years. All right. Now, please, as I said, ladies and gents, please try and avoid rounding off too early, right? Rather, you work out with all of the values that you have. But when you put it in your calculator, please just put there and say answer. And then you say answer plus, this whole thing here. And again, you find the answer. And then you say answer plus that final value over there. Right, so please try and avoid having too many steps. You'd rather do all of the calculations in your calculator. Write the formula and you write the substitution thereof and then just put everything on your calculator. All right, I hope that has been very clear. All right, I want us to take another example wherein there is a withdrawal this time. Okay, right, let's go to our next example. All right, so let's take our next example. So we've got 120,000 that was invested in the bond market, okay, for 5 years, and the interest rate was fixed at 11.25% per annum, right? And they said they compounded it quarterly, right? Very important for us. So that's important information. And so we've given the time, and then they said it was invested at that rate for 3 years. And then changed to 9.75% per annum compounded monthly. So now we are changing the compounding period, right? So, the compounding amount, interest as well as the period. So in this case, they say one withdrawal of 40,000 was made after 18 months. Okay, so we are withdrawing an amount. And in this case, they want us to calculate how much money was available at the end of 5 years. Now, let's quickly do that. Right, and as I did say, it's the timeline. What a timeline does is that it really, really summarizes your data quite nicely. So let's have here 1, 2, 3, 4, and here 5. Okay, that's T1, T2, T3, T4, and T5. Now, in this case, what we're going to do is that we know that we had an initial amount of 120,000 rands, okay, that was deposited. So let's deal with the 120,000 first. But what we need to remember is that, it was compounded at 11.25%, all right, and this was on a quarterly basis for 3 years. So in this case, I'm going to look at the first 3 years and see that in this case, it was at 11.25%, okay, per annum, and this was on a quarterly basis, okay. So once again, on a quarterly basis, and then we note again, it means that within the next 2 years, now the interest rate, I think, had changed to 9.75%, so that's 9.75% per annum. And in this case, we were compounding it on a monthly basis. So we want to find out what would be the return that we would get in this case for the 120,000. However, we do also note that there was a withdrawal that was made. And remember, it was made at 18 months. That's 1.5 of a year. So in this case, we made a withdrawal. So that would be here of 40,000. Okay. And in this case, remember that the withdrawn amount would also have accumulated interest until this point here, right? So we're going to deal with that separately. Now, first of all, let's start with the 120,000 rands. Let me tell you what I'm going to do. I'm going to deal with the 120,000 rands as though it, was invested for the full 5 years. So I'm going to look for the accumulated amount until this point here, right? And use that accumulated amount at year 3 as the principal amount for when we change the compounding, the rate, the interest rate in that case, right? And thereafter, what we will do is then deal with the withdrawal, okay? Because we withdrew the amount. But remember, that withdrawn amount also accumulates interest in a sense, okay? So within the 1.5 of the year that is remaining, right, at 11.25, and thereafter for the 2 years for the 9.75 period. And what we're going to do at the end of the day, going to take that principal amount and subtract it from that withdrawn amount. Right, now let's do that. So I'm going to do that in the white. Let's start with the initial deposit. Let's call it A1. So what we did here is that this is going to be P1 plus I over M. That's going to be N times M, right? So I'm dealing with the principal amount up until year 3, all right? So in this case, that would be my principal amount, that's to 120,000 rands. That's going to be 1 plus, the interest rate was at 11.25%, but remember you divide by 100, so that's 0.1125 divided by 4, that's quarterly, and in this case, that's the 3 years multiplied by the 4 quarters, obviously in 1 year. Now, it would give us an accumulated amount, but remember, that accumulated amount now earns interest. Let me do that in the blue so that you understand that it now earns interest at 9.75, right? So in this case, it would be plus, so that's 0.0975. Remember, this is now, the compounding interest for the last 2 years. So in this case, divided by 12, because remember now, it is earning interest monthly, okay? So that would be 2 years multiplied by the number of months in that year. So again, like I did in my first example, I'm not going to calculate the final amount here. I'll do that all together when I do it in the calculator. All right, now let's go for the 40,000. All right, if you want to, you can calculate that and tell me what you get. Okay, right, now let's go for the 40,000. We had written that in yellow. Okay, let's call it A2. So we are looking at the 18 months. Now remember, this is half a year plus another full year at 11.25% per annum, right? So in this case, I'm going to find the accumulated amount, right? So that would be P1 plus I over M, N times M. So that's the 40,000 that was withdrawn, that would earn, or that would also accumulate interest at 0.1125 over the 12, over 4 rather, that would be over 4 in this case, and that would be for 1.5 of a year, so that would be 1.5 multiplied by 4. Okay, now of course thereafter the accumulated amount at this point here, right, would now earn interest over the rest of the 2 years that are remaining at 9.75. So in this case, that would be 1 plus 0.0975 divided by In this case, that's 12. But remember, we've got 2 years. And in this case, we have got 12 months in a year. Right. Now, all we're simply going to do is make sure that to find the final amount, okay, that would simply be A1, which was the deposited amount, minus the withdrawn amount, A2, right? So in this case, let's just quickly put that in our calculators. Let's remember what we got there. And in my case, okay, if I look at that, okay, because I had done that, trying to see where I wrote that amount there. Okay, so I got an amount. So when I subtract those two, please remember you work in your calculator, work with this value first. You find the answer, you keep that answer in your calculator, and then you say minus, the amount here, and you put all of it in your calculator. Please, ladies and gents, avoid writing a lot of things, otherwise then you have a high chance of making mistakes. So that would be 145,902 rands and 52 cents. Of course, for those of you who are in other countries, you would use the currency that you guys use there. All right, and I hope that has been helpful. All right, I hope you've enjoyed that lesson, and don't forget to subscribe, hit that subscribe button. And of course, as I did say, for those of you who need assistance with mathematics or physical science, you're more than welcome to get in touch with us. And we did say our email address is info@mlungisinkosi.co.za. And please don't forget to share and like. Just hit that like button at the end if you really enjoyed this lesson. And I'll see you guys again next time. Sharp, sharp.